quadratic inequalities. First, let's take a look at this example. Find the set of values of x for which x squared is less than 10 minus 3x. To solve a quadratic inequality, you need to rearrange it so that the right hand side of the inequality is 0. So, rearranging x squared less than 10 minus 3x gives us x squared plus 3x minus 10 less than 0. Then, solve the corresponding quadratic equation to find the critical values. So, x squared plus 3x minus 10 equals 0. Factorize, so it's x minus 2 times x plus 5 equals 0, x equals 2 or x equals minus 5. After solving the corresponding quadratic equation, sketch the graph of y equals x squared plus 3x minus 10. As you can see here, this is the graph of y equals x squared plus 3x minus 10. As we saw earlier, x squared plus 3x minus 10 is less than 0 and hence y is less than 0 as y equals x squared plus 3x minus 10. So, if we take a look at this graph, y is less than 0 for the shaded area inside the graph below the x-axis. And hence, the solutions to the inequality x squared plus 3x minus 10 less than 0 are the x values when the curve is below the x-axis. So, the solution is x is greater than minus 5 but less than 2. Find the set of values of x for which 6x squared plus 11x minus 10 is greater than 0. So first, solve the corresponding quadratic equation 6x squared plus 11x minus 10 equals 0. Factorizing gives us 2x plus 5 times 3x minus 2 equals 0 and hence x equals minus 5 over 2 or x equals 2 over 3. Now, sketch the graph for y equals 6x squared plus 11x minus 10. Since 6x squared plus 11x minus 10 is greater than 0, y is greater than 0. So, if you take a look at our quadratic graph, you can see y is greater than 0 for the outer parts of the graph above the x-axis as shown by the shaded area. So, y is greater than 0 when x is less than minus 2.5 or when x is greater than 2 over 3. And hence, the required set of values is x is less than minus 5 over 2 or x is greater than 2 over 3. Now, let's take a look at a few more examples. Find the set of values of x for which 25 is greater than 1 over x squared where x is not equal to 0. First, rearrange the inequality so the right hand side is equal to 0. So, multiply both sides of the inequality by x squared and you get 25x squared greater than 1, 25x squared minus 1 greater than 0. Solve the quadratic equation 25x squared minus 1 equals 0. So, x equals 1 over 5 or x equals minus 1 over 5. As you can see, this is the graph of y equals 25x squared minus 1. So, 25x squared minus 1 greater than 0 and hence y is greater than 0. Y is greater than 0 for the outer parts of the graph above the x-axis as shown by the shaded region and hence the solution to 25 less than 1 over x squared is x is less than minus 1 over 5 or x is greater than 1 over 5. Find the set of values of x for which 2 over x is less than 1 where x is not equal to 0. Here, x could either be positive or negative, so you cannot multiply both sides of the inequality by x. Instead, multiply both sides by x squared as x squared can never be negative and since x is not equal to 0, x squared is not equal to 0. So, multiplying by x squared gives us 2x less than x squared, 2x minus x squared less than 0. Solve 2x minus x squared equal to 0. So, factorizing gives us x times 2 minus x equal to 0, x equal to 0 or x equals to 2. The graph shown here is for y equals 2x minus x squared. So, 2x minus x squared is less than 0 and hence y is less than 0. Y is less than 0 for the outer parts of the graph below the x-axis shown by the shaded area. So, the set of values of x for which 2 over x is less than 1 is x less than 0 or x is greater than 2.